Well, hello and welcome back to an Antisyphon live stream. I'm Jason, and apparently I have a live stream voice, like my daughter says. So here it is. Today with us, we got Serena. She networks on the internet. We got Ryan here, who will be pretty much quiet the whole time, just stay in the background unless he has some kind of witty joke to just throw in from out of nowhere. Mostly, he just makes our faces big on the screen and then makes us feel super self-conscious about it. And then he moves on to the next person. So that's what
I
Ryan does.
hit buttons.
Okay. But what we really got today is Carrie Roberts here, who is our guest presenter, and she's going to talk about Atomic Red Team today. And if you don't know what Atomic Red Team is, you're about to find out. And so if you're like, I've always wanted to know about Atomic Red Team. So Carrie, you're like one of the people who helps maintain Atomic Red Team, and like you've done a lot of the work on Atomic Red Team. And so you're like, would you say you're an expert on Atomic Red Team, or does that word give you like a weird
Oh,
feeling?
oh, totally. Mega expert.
Yeah.
I have been doing a lot with it since I got involved in um, about 3 years ago. I It's open source, so I started playing with it, and I decided it was too hard to use, and I wanted it to be different. So I got in there and used the power of open source to make it improved in the way that I wanted it, and luckily those got approved. And so now I help people understand how to get started because my journey was a little rough trying to figure that out. So I thought I'd share that with everyone.
Sure. So you're going to talk about Atomic Red Team, so let's go ahead and get to it. And then if we have any questions, we'll go ahead and throw them up from time to time. But go ahead, Carrie. Ryan, bring our full screen. There we go.
Yeah, this is my first time on Restream, but that countdown was like amazing. I hope I can keep up the status quo after that countdown. Man, I'm jazzed. So we're going to have a little talk about getting started with Atomic Red Team. So this is actually leading you into a bunch of hands-on labs that you can do if you actually want to start using Atomic Red Team. I'll demo how to do it here. So if you're just here to get a general knowledge about what Atomic Red Team is and why you might want to use it, you're going to get that. But also at the end, you'll have links to 7 hands-on labs that you can do in your own virtual environment, which would get you to a level that you could actually, start using this for various purposes, which we'll talk about. So let's click here. So just quick introduction of myself. I started out as a web application developer, and back in 2010, my web app was security audited or pen tested. I didn't even know what that was at the time. The report came back with critical vulnerabilities, including SQL injection and cross-site scripting everywhere in my app. And at that time, in 2010, I had never even heard those words. I didn't know what cross-site scripting was, and I didn't know what SQL injection was. But I read the report and I learned, and I was in disbelief, but I went and checked my web app, and sure enough, it was completely hackable. So after going home depressed and thinking maybe I'll quit being a developer because I don't know anything about security, and then going from being depressed to being mad at my school for not teaching me about it back in 2006 when I got my degree in computer science, I finally came around to my senses and decided to embrace the idea of learning about security. And so I sought a degree in information security and learned a lot about that, and ultimately ended up working with the Atomic Red Team, which I'll tell you about here. And I am a maintainer of the Atomic Red Team project, which means it's an open source project that if you have a contribution you like added to the project, you could propose that, and then a maintainer like me would review it, and if it looks good, we'll make it part of the project. So we'll talk more about that as well. So Atomic Red Team is a library of scripted cyber attacks. So it's like a book, and you open up the book and you say, if I wanted to do password spraying, uh, what commands would I type in, or what programs would I run to do a password spray? And it will have, it's kind of like a recipe book, a bunch of different recipes for doing password spraying, because there's a lot of different ways, tactics, and technique that you could do that. So the Atomic Red Team is a library of scripted cyber attacks. It's not a tool in itself, meaning there's no like script in it where you say, please run this scripted attack and this one and this one. It's literally just let's say a web page full of commands that you could copy and paste out. Now there are tools that can use this library and automate it for you, called execution frameworks. But that's outside of directly the Atomic Red Team project. The project is really just this library of attacks, which you can do with whatever you want. You can automate the reading and execution of that. You can just learn from it. You can copy and paste. So this project was started back in 2017, originally by the Red Canary Company. They do managed service. They're a managed service provider, and they do security research and incident response work. But they open source that, and they continue to support it just with additional maintainers and some resources like Slack channels for the community to talk about. And they provide t-shirts for contributors, so they're still an awesome supporter. But more than half the maintainers of the project actually don't work for Red Canary, and so it is a community developed project. There's over 250 different contributors, and you could be one of those. So you see a little glimpse into the library. We're going to take a deeper look, but it's hosted on GitHub, because that's a great place where you can share code-like projects in which a lot of people can contribute without overriding each other's changes. So we'll take a closer look at that. This live stream is really a subset of a larger 14 or 16-hour class that I teach, which covers other topics, including MITRE ATT&CK and some other execution frameworks like Vector, Prelude, Caldera, and more. So if you end up taking that class, you'll get a repeat of this live stream section where we're talking about Atomic Red Team here. So first we'll start out why we would want to know these scripted cyber attacks, and in order to emulate them. Why would we want to take these commands from a library that says use these commands to do a password spray inside of your Active Directory environment? Why would we want to take that and do that? Well, we want to be able to answer the question of how prepared we are to defend against attacks. So if your manager says, hey, if such and such APT group comes into our environment and they're known to do this type of password spraying, would we detect it? Well, that's a really hard question to answer without actually doing that exact command and seeing what happens. Does it get blocked? Does it get detected? What products detect it? Because without doing that, you're really just kind of going on a strategy of hope. Like, well, we pay for a product X, Y, and Z, and they cost a lot of money. They're supposed to be protecting us from all the things, so I hope so. But you won't know until you actually do that. So if you have the knowledge, the actual commands to emulate in that in your environment, so you can actually do that attack or a version of an attack that doesn't do anything malicious other than behave in similar ways, then you can say definitively, yes, we blocked that, or yes, product A and B have us covered on that, or no, we're missing a detection. And if you find out you have a detection gap, you could then go back and figure out why you have that gap. Is because you don't have the right alert logic written to find that happened, or maybe you find that even if you had a detection, it wouldn't work because you're not gathering the telemetry that would let you determine that attack happened. So maybe during a password spray, a certain Windows event gets created, but you don't keep a copy of that happening, so you're not going to be able to detect it. So when we emulate this attack, now we have this kind of needle in the haystack. We know that a password spraying has occurred in our environment, and we can try out our alert logics and say, are we able to, if we wrote our own alert, could we find that this happened because it's a detection gap right now? Or maybe we say we could figure it out if we kept track of certain events in our environment, which we're not keeping now. So we could use that to tune our configurations and say, I want to make sure I keep track of this, and this telemetry in order to be able to know that certain attacks happen. So we can correlate what telemetry we want to gather and keep with what detections we're trying to write, and we can justify needing that additional telemetry. And when we emulate attacks, we can verify that a long chain of things is in place and functional. So I have this chain over here on the right. So and it's really just a subset of all the links in the chain that have to be in place. But we have to be capturing the right events. We have to forward those events. So all that network stuff has to be working, and the storage place where we store it has to be storing things and not losing data or getting behind and dropping packets. We need to have the right alert logic written to find that. We have to have an analyst who looks at the alert when it goes off and decides if it's true or false positive. If it's true positive, we want to see that that gets through the people process of being raised as an incident. So when we emulate this, we can validate that everything in that chain works. And since it's scripted, we can do that repeatedly. So maybe every week we run many scripted cyber attacks, and we validate that all the links in the chain are working. We can also evaluate, like shown in this graphic here, our security products. So maybe we have product B that when we emulate several hundred attacks, we find that product B covers this much of the space, product A covers this much, which is some overlap with B, and then product C covers an amount that just overlaps with A and B. So it's not providing us any additional value. And at that point, you could justify possibly getting rid of C, as it's just duplicating and providing no new functionality for you. But before we jump completely into Atomic Red Team, we really need to make sure we're all on the same page with MITRE ATT&CK. So MITRE is a government-funded R&D organization. One of the projects that they work on is this MITRE ATT&CK matrix, which is in grid form like this, where they, across the top in the red box, they list out general tactics that attackers use, and they get this information from input from companies across the globes on actual attacks they're seeing, not just theoretical or not theoretical attacks only things that are actually being used by actual attack groups against organizations across the world. And so in general, the threat groups are using certain tactics or groupings of techniques. So first they try to get access to your computing environment, the thing they're trying to hack. So that's initial access. And then once they have access, maybe that's walking in the back door, maybe it's mailing a USB stick, maybe it's sending a phish. Once they get access to your computer, of course, they want to run code to accomplish their objective, which could be getting credit card information, for example. And one of the first things they want to do with that code execution is maintain persistence. So the third tactic is persistence, because they've worked so hard to get access and code execution. They don't want to lose that if the person's computer they compromise turns it off for the night and then restarts it in the morning, or it disconnects from the network or whatever. They want to make sure that when that comes back on the network, they still maintain access. So there's several techniques within that tactic of persistence that attackers use. So I won't go through all of these, but these are the general categories of techniques that attackers use, called the tactics. And within each of these tactics, going down in the blue, so under the tactic of credential access, there's several techniques that they use. So they might try to get additional credentials by brute forcing passwords, stealing passwords from your password stores, so like your browsers, for example. They might sniff passwords on the network, so just watch network traffic. They might install a keylogger, so under input capture, they install a keylogger. So these are laid out tactics and techniques. And then in MITRE, you can click on each one of these and get more details. So you can get examples of groups that use this technique and ways that you might be able to mitigate this threat to you or detect it. So lots of good information, but one thing they don't have in the MITRE ATT&CK is a nice recipe book of all the different commands you could use, the different ways to do each of these techniques. And that's where Atomic Red Team comes in and fills that gap. You've got MITRE giving you the tactics and techniques, and Atomic Red Team coming in and giving you the procedures for each of those. So in MITRE, each of these techniques has a technique number. So it starts with the T and then is a 4-digit number. Sometimes has a sub-technique number. So some techniques are broken down into smaller subcategories. So here we have T1003.001, so sub-technique 1. So that's important point out because Atomic Red Team is all organized by these technique numbers. So we could go into Atomic Red Team T1003 and see all the scripted ways we have available to us to do this particular technique. Now we're jumping into Atomic Red Team, the procedures, and I'm going to show you some examples of scripted attacks, starting with some simple examples and working our way up to a little bit more complex examples so you get an idea. So here we are. We're looking at one test from technique 1548, and it's called Disable User Account Control using reg.exe. Reg.exe is built into Windows and can modify the registry. So this is atomic test number 8. So this scripted cyber attack that it describes here is what we call an atomic test, meaning one unit test, one scripted cyber attack. It does one thing. So it isn't emulating a whole threat group. It's not following a path like threat groups tend to use the same tactics and techniques from campaign to campaign, and as long as they're working for them, and only modify it slightly. So if you wanted to emulate an entire chain of events, you would have to run multiple atomic tests together because they're really like unit tests. So here we have a description of what this atomic test is, or what the scripted cyber attack is. It says what platform it's for. It could be Windows, Linux, Mac, and multiple cloud or container platforms, which I won't list out here. So the library covers all of those platforms. They're the same platforms that MITRE attack defines. And then here we have the attack commands. So it says run this with command prompt, which has to be running as root or admin in order to run this. So we could read this and we could just follow these examples. So we could copy out this command line here that sets a certain registry key to 0, which will disable user account control. User account control is that thing that pops up and says, do you really want to allow such and such a program to modify your computer? Yes or no. So anytime you run something as admin, that pops up. So an attacker is going to it's going to be desirable for an attacker to disable that so that when they want to run some code that's going to compromise your system, that won't pop up and you won't get suspicious. Why is this program running when I didn't just start something? And the attacker doesn't want to wait for you to push yes or worry that you might push no. So this is a technique they use by disabling user account control, that pop-up warning. So we could just start up an administrative command prompt shell on our test system. We could copy this out, we could paste it in and press enter, and it will change that registry key. And at that point, we've emulated this attack of disabling user account control in this way. There's actually, we can see we're on test number 8. There's at least eight different ways to do it, and that's one of them. So at that point, we could go, well, we could see if it actually changed the registry key. Did it get blocked from doing that? If it didn't get blocked, can we detect that happened? Because probably in our environment, since that's not the default value, it's unusual to see people changing that to be disabled. So then we might want to say, hey, we really don't get any notification when that gets changed. We don't have any good reason why people should be changing it. We think only attackers would be doing it. So let's go ahead and write an alert so we can be notified if somebody changes this. And then in addition to the attack command, we have a cleanup command. And so the Atomic Red Team library just provides us a handy way to kind of reset our system back so that we could run the atomic test again, or at least not leave our system in a non-default, more vulnerable way. So here we have basically the same command, but it's changing the registry key value back to 1, which is the default value where UAC is enabled. So in a nutshell, that's Atomic Red Team. You've got a command to run to emulate an attack, optionally some cleanup commands or prerequisites that you need to install that are automated for you. And there's multiple variations all tied into the MITRE attack numbers. So you can cover a large part of that MITRE attack space on their matrix by emulating attacks with the Atomic Red Team library. Here's another example, under technique 1003. where we're dumping a copy of 3 different registry hives that contain credential information. So if an attacker gets a copy of these, they can take them offline and pull out passwords and hashes that they could use to compromise your system. So here it says command prompt again. As admin, you could just copy and paste these 3 commands and it would make a copy of those. So that would be something to watch for in your environment, because I don't know of any legitimate reason to be making copies of these files other than if somebody's trying to get credentials. Our third example of an atomic test here is T1078. And this is enabling the guest account and allowing it to RDP. So Windows by default comes with a guest account already added to the computer, although it's disabled, so nobody can log into it and use it. But it can be enabled without actually adding a new user. You can just enable a user instead of adding a new one. So as a way to avoid being detected, an attacker could, instead of adding a new user, which they worry might get detected, they could just enable an existing user and that may not be detected. And on top of that, what would be especially weird is if somebody enabled RDP access, so allowed the guest user to RDP to the computer. So that would definitely be something that should raise eyebrows in your environment if you see that happen. And is also probably something that doesn't get blocked by default, because it's really, really not in it of itself malicious, although it's unlikely anybody's doing it for any other reason. So another good thing to emulate and validate what's going on in your environment, whether you detect or block that, or if you could add a detection for that and be notified. So that's the library. Library is just a list of commands. Run these commands to attack, run these commands to clean up or install prerequisites, but there's no automation built into it. Now you back up, but it's really where all the value is. You've got this huge library of scripted cyberattacks. So then you back up one level from that and say, okay, I really like this library, but it'd be nice if I could script the execution of it, because I'm getting tired of copying and pasting commands out. Plus, I want to run it like around the clock, maybe. So I want something, an execution framework, something that knows how to read the library, follow the instructions, and do it accordingly. So if it's supposed to be in command prompt, it'll run it in command prompt with elevated or not elevated privileges. If it's supposed to be in PowerShell, it does it there. So it just does everything for you and makes it easier and can be scripted. So there's a lot of different execution frameworks. Really, the value isn't really in the execution framework here. It's in that library. But we will cover an execution framework, and I'll demo that today, called Invoke Atomic Red Team. It's also provided as an open source project through Red Canary. And it works cross-platform if you install PowerShell Core on Linux or Mac OS. But there's also other execution frameworks. There's a Python one, which of course would work out of the box on Mac and Linux. There's other non-command line versions of execution frameworks like Prelude Operator, which has a free community version, or MITRE's Caldera project, which is also an execution framework that has Atomic Red Team built in. That's free and open source. So lots of different execution frameworks. So don't marry yourself to the idea that the value is really in the execution framework. It's really in the library, and you get to pick and choose what execution framework works best. But we will be showing the PowerShell execution framework, and that's what the labs will do, because it's just an easy, straightforward framework for getting started. I'm going to back out of the demo here, and I'm sharing my screen from actually one of the lab VMs that you would be installing. I've got it running here in VMware Workstation Player. So what it is it's a development version of Windows, and evaluation version of Windows that you download from Microsoft, and then you just run a little script that I provide, and it'll put Chrome on here with the different bookmarks that I have. So you'll have these same bookmarks minus the webcast bookmark, and you'll have these Notepad++ and these links here. So your test VM will look just like this. And so I'm going to use this bookmark over in Art, Atomic Red Team, and I'm going to go over to Atomic Red Team GitHub. So we come here and we see this GitHub repository, and it's a little overwhelming because there's all this stuff, and you're like, oh my word, how would I ever learn what all this is? But the good news is that most of this stuff just is supporting files for the project that support some of the automation. So for the most part, nobody needs to pay attention to any of this except for this atomics folder. So the atomics folder has the library in it. So if we click atomics, we see that with the exception of this first folder called indexes, that everything's named by its MITRE technique number. So this is how it ties back directly to MITRE attacks. So if there's a technique folder here, it means Atomic Red Team has at least one atomic test written for it. There's actually something we cover in the class called the MITRE Attack Navigator. It's an interactive view of the MITRE attack matrix, but you can kind of overlay colors and put comments on it and create a heat map. I have one of those created here to show you how well Atomic Red Team tests, the procedures, cover that MITRE attack matrix. So I'm going to load up under MITRE attack the MITRE Navigator Atomic Red Team coverage. I'm not super fast. And we can see that at a glance, I mean, it's obviously hard to read here, but you can get a general idea that the majority of these techniques in the MITRE attack matrix have at least one atomic test written for them. So you see all these where they're red. So you can emulate those techniques at least with one test, and in many cases a lot more than one scripted cyber attack using Atomic Red Team. And so we can right click on some of these, and you can go to view atomic. So under browser bookmark discovery, if we click view atomics, it takes us right over into Atomic Red Team and shows us the atomic test we have for this technique, bookmark discovery, and there's 8 of them. So that's cool that the two projects tie together. It's also cool that the Atomic Red Team library covers such a large space of the MITRE attack matrix. So back to the project here, we have all these technique numbers. Inside of each one of these technique numbers, you'll find a minimum of 2 files, the technique number.yaml and technique number.markdown. The YAML file is the official source for the scripted cyber attack, but you can kind of make sense of it. You see some names of tests, you see some commands, but it's really hard for a human to read. So this GitHub project, creates this markdown version, which is displaying the YAML file just in a friendlier way. So if we open up this markdown file, now we have the name of the right from MITRE attack and a description from MITRE attack, just to keep us from having to go back and forth between MITRE attack and Atomic Red Team to see that. And then it lists out the test, and we can hyperlink to any of these 8 tests, for example. So let's look at the first test. It's system network configuration discovery on Windows. So we have these 5 commands that are typical reconnaissance type commands that threat groups will run when they get environment to orient themselves and decide on their next steps. Let's scroll down. Here's test number 3. This one's the same name, but it's targeting Mac OS and Linux. So we got Mac OS and Linux type commands. And then you optionally have inside these folders, you'll optionally have a source and a bin directory for supporting files. So maybe the atomic test runs a batch file, a script, and that would be located in the source directory, or maybe it runs an executable, and that executable would be in the bin directory or the binary directory. So, but at a minimum, you'll have the YAML and the markdown file. I want to point out it's really important to realize that both these projects, Atomic Red Team and Invoke Atomic Red Team, have a nice wiki. So here we have a wiki with the whole getting started. There's even a whole section on contributing to Atomic Red Team. So a lot of advice about how to get started, even a video here about how to create a pull request, which for a lot of people, they haven't done that before in GitHub. And pull request is just a way of contributing where you say, hey, I have this new atomic test I want to add. can you look at it, and if you like it, put it in the project. And there's a formal process for doing that. And this video shows you how to do it all through the web interface, so you don't have to learn hard GitHub command lines or anything. So there's a nice video here. And even your first time contributing, you get a free Atomic Red Team shirt the Red Canary will send to you. So we appreciate their support on that. Okay, so I'm in Red Canary Co's GitHub repository, and I'm in the Atomic Red Team project, which this is the library. But if I back up one level to Red Canary Co., I've got Atomic Red Team here at the library, and then I've got the execution framework, Invoke Atomic Red Team. So if I go to Invoke Atomic Red Team, and similar story here, there's a lot of stuff here, but really just check out this wiki. The wiki is very similar to the labs I have you walk through, probably because I wrote the wiki and I wrote the labs, and that's the good way I think of going about it. But it tells you how to install the execution framework, how to import the PowerShell module, how to use it to list atomic tests, get and check your prerequisites for a test, execute tests either locally against the machine you installed Atomic Red Team or remote against a machine across the network. We don't cover that in the labs, but it can do that. You install Atomic Red Team on your machine, but you execute tests against a remote machine. You can change some of the arguments that are used with commands to customize it without having to change the library. And then you can run cleanup commands and several other helpful things there that you can look at. So with that said, I have Atomic Red Team already installed, although if you do the labs, your first step will be installing Atomic Red Team. It's just a couple PowerShell commands, and it'll walk you through all the problems you're going to run into when you try to install it, or could run into, like Windows Defenders blocking you, or scripts being disabled in your environment, and etc. So the labs are very verbose and help you work through those issues. So since I have Atomic Red Team already installed and imported, or the execution framework, I can use this command called invoke atomic test. And usually you put a T number here, like T1016, but just for show, I'm going to say all, which is a magic thing that says show me everything, not just a specific technique. And I can say show details brief. So the brief details are just the title and the technique number. So if I do that, we can see, scan across the screen, all the atomic tests that apply to Windows. Because we're running this on Windows, it's showing us just what applies to Windows. So we see, T1036 subtechnique number 3, and the name of all the tests we could choose to run. So I just like to show that because it kind of gives you an idea of the scale. There's around 800 tests for Windows that you could choose from to run. So I'm actually going to cancel out of that so we don't have to watch that all. So I'm going to say invoke atomic test. I'm going to pick a specific technique number, T1016, that we just looked at on the web. And I'll say show details brief. And we have these tests. So the first one is system network configuration discovery on Windows. And then notice we're missing test number 3. That's because test number 3 was that Mac OS and Linux test. So we didn't have it. We're not going to be able to run this right here because we're on Windows, so it doesn't list it. So we can kind of ask this execution framework to show us what the markdown file shows us. So if we erase the brief afterwards, we can say show details, and then it gives us I wanted to do it for test number 1 specifically, so I can say test number 1. And so here we have the same information that's in the markdown file, just laid out a little different way. So we have command prompt. It says you just run these commands. At this point, we could copy these out and paste them into command prompt and run them. But we have this execution framework to do things for us. And if we erase the show details and we just ran it like that, it would actually run those commands. So here we have the output of running those reconnaissance commands, the same as if we would paste them in a command prompt, and they were run in the command prompt for us. So not tons easier than just copy and pasting it out. But we're going to look at some examples where the execution framework really starts to help us as the atomic tests get a little more complicated. So I got to bring up my notes here. We're going to look at let's clear this. We're going to look at T1548, test number 8. Instead of saying dash test number, you can use this shortcut of just dash and then the test number. So test number 8, and we'll say show details. And test number 8 is that first atomic we looked at, using reg to add or to change this registry key to 0 to disable user access account control. So if we tried to run this we can also use a flag that says check prerequisites. Like, do we have everything we need to run this test? So if we do check prerequisites, it says, nope, you have to run this from an elevated shell and you're not elevated. So if we ran it from here, it would go ahead and try to run it, but it doesn't have a chance of succeeding. So we could do that here, and it says access is denied. So then we would also know that we have to run this from just checking the time here. So we would have to run as administrator, and then we'd have to run the same command over there. It says the operation completed successfully. We actually have to restart our computer before it takes effect, but we won't do that right now. So let's look at these details again to remind ourselves. This is setting this registry key. So whoops, I did want that on there. Let's go look at that registry key with PowerShell. And actually, I'm just going to copy and paste this. I already have it written up. So I'm just asking PowerShell to tell me the value of this registry key, enable LUA. And we should find that it's 1 because it just said it did that for us. So enable LUA is 0. So we didn't check it before to confirm, but we will check it after we run the cleanup command. So here we have the cleanup command that just changes it back for us. So maybe we're done developing our detection or finding out if it gets blocked or alerted. And now we just run dash cleanup, and it'll run the cleanup commands. So here it says it happened successfully, and we check the registry key, and now it's checked back to 1. So that's how that works. So that was handy because to run this test and clean up after it would have been 2 copies and paste, but we can just do that with the execution framework. Next, we'll look at an even more involved test, which is T1485, because it has some prerequisites. Atomic test T1485, and we'll show details brief to remind ourselves of the test. And we want to look at test number 1, overwrite a file with sysinternals sdelete. So sysinternals has a bunch of tools. It's Microsoft that makes sysinternals. They have a bunch of tools to do kind of handy stuff, but sometimes attackers like to use them too. So they have a tool called sdelete to securely delete a file. So normally on computers, if you delete a file, it just marks that space as available. It doesn't actually erase stuff until something else gets written over the top. But if you use something like sdelete, it will actually write over the top of that file with a bunch of zeros and ones so that it's not recoverable by someone doing forensics. So attackers like to do this in order to make it harder for the blue team, the defenders, to figure out what they've been up to. So let's look at test number 1 in more detail. So show details. And here it says it overwrites a file with sdelete, but it has this dependency section. So one dependency is that the secure delete tool from sysinternals must be on disk at the place that the arguments specify, which by default is in the temp directory. So And the attack commands are if the file to delete doesn't exist, create it, and then call sdelete on it. But this little hashtag squiggly syntax and what you see in red here are the input arguments. So this atomic test is configurable. We could specify whatever file we want to delete when we emulate this attack. And we could also specify a different location for sdelete. So maybe our sdelete executable is in the C tools directory, and we could just specify that when we run this atomic test without having to change the atomic test. So we can use arguments. And so here we have the commands with the variables listed in red, but then we have commands down here with the input arguments filled in or their default values. So here's the default value for the file to delete. And here's the default value for sdelete exe is in the temp directory. But the execution framework can also help us specify different than default arguments, which we could show you later. Okay, so it says we have to have the sdelete tool in our temp directory, and we don't have it yet. It doesn't come on Windows by default. So if I do check prereqs, it'll tell me that. It says, nope, you don't have secure delete tool where we're looking for it in the temp directory. And it says, try getting it with the get prereq switch. So now we're starting to see the power of having an execution framework, because we wouldn't want to have to put in all these variables by ourselves and download all these prerequisites ourselves when we could just run the scripted one. So we could say get prereqs. And now it's downloading the zip file from Microsoft. It's unzipping it and putting sdelete in the temp directory where it expects it. And now it says prerequisites successfully met. So now if we run the test, it'll create that T1485 file and then securely delete it. So here it created the file. And here it says sdelete deleted T1485. So as an example of how you can use the execution framework to change those arguments, I can put on the desktop a new file here, new text document, erase me. And then when I run this test, I could use this prompt for input args. And so first it says, where's your sdelete executable? And you could just press enter if you want the default value, which is shown here. So I'll just press enter. And then it says, what file do you want to delete? So in this case, I could do C users art desktop erase me.txt. And that's the last of the input arg. So we see this disappear. And so that shows you how you can configure these to work in your environment. So everybody can use the same atomic test library and yet still configure arguments for their own environment. Okay, we have 15 minutes left, so I'm going to go back into the slide presentation. Let me find my place first. Uh-oh.
Carrie, while you're doing that, I just wanted to say Haxoring Pirate. Thanks for following. Sapien, thanks for following.
Wow.
31D, thanks for following. And if anyone here wants to subscribe, you can always do that too. You can be a subscriber of the Antisyphon Twitch. And if you're like, what are you talking about? We're on Twitch and LinkedIn Live and YouTube. So we're trying to make sure that anyone who wants to learn can learn from Carrie. And I don't know, maybe me. I could probably teach something. Serena, you could teach something sometime too. I think you did it yesterday. And Serena's going to start doing walkthroughs of the cyber range. So I'm excited about that. We just got to get her on the schedule. All right, Carrie, it's all back to you now.
Okay, thanks. Thanks for covering while I figure out how to use PowerPoint. Okay, so some things I didn't talk about is that the execution framework also logs execution. So every time you run those attack commands, it'll create by default, just a simple CSV log that says what time it ran, what technique number, what test name, what the username. I didn't talk about the GUID, but each test has a GUID, and that's guaranteed never to change. So when you get into where you're scripting execution, it's really good to use that GUID, because the test numbers can change and the test names can change, but the GUID doesn't. And it also says what host it ran on. So it's a basic log. It doesn't record the output. And if you're wondering, hey, does this tell you whether the test was successful, worked or not? No, that isn't built into Atomic Red Team. It's actually a very hard concept to build in, because everybody defines success differently. And some tests, it's really hard to tell, if it worked or if it didn't. So no, there's not built-in success, but you can use your detections as a way of validating that something happened or didn't. There's also much more verbose way to log, which you can read about on the wiki there. It logs in JSON format, and it includes every command run with a timestamp and all of its output. And so that's much more verbose, and it's also importable into the Vector Purple Team reporting tool, which is also free, and it's not open source, but it's free to use. It's an excellent way to track your campaigns when you're doing attack emulation and recording how your blue team side did with that. And we also cover that in the longer class. So how you might set this up in your environment is you may take a computer that's set up like you may give to your typical employee when they start at the organization, probably not necessarily admin privileges, just with your standard software on it. I've got the G here to indicate that's like a golden image. It's your standard image you give to people, standard setup. And then you may install Atomic Red Team on this, and then also execute atomic tests against that same machine where you installed Atomic Red Team. And then you may or may not have your blocking controls turned on. I always recommend that you at least do your attack emulations with blocking controls turned off, because with my experience in pen testing and red teaming, which I forgot to mention, that after I finally took the bull by the horns and learned about Infosec, I ultimately became a pen tester for 3 years, then red team for a couple years, and then blue team. So in my experience in pen test and red team, I know that there's always ways, never-ending ways, to get around blocking controls with AMSI bypasses, for example. And so as a defender, I want to make sure that even if the attacker is able to get something to run, I at least detect that. So I have this quote that I heard when I was in SANS: prevention is ideal, but detection is a must. So I agree with that. So in this scenario, I would turn off blocking controls. I might run it again with blocking controls on, just so I can compare what we would block versus what we wouldn't, assuming no bypasses. And then you could ship off that telemetry from that test machine actually to your production logging system, as if this stuff had happened in production. And then you can validate your production alerts, even though you're not necessarily testing on a production machine. Also, when you get more comfortable with Atomic Red Team and certain atomic tests, you could consider running those on actual user endpoints. Another way to do it is you can install Atomic Red Team on any test box you have, Windows, Linux, Mac, and then you could use the remote execution method to execute against your typical system. And this has the benefit of it's very light touch on that remote machine. All that remote machine runs is the attack commands, the cleanup commands. It doesn't have to invoke Atomic Red Team, which includes a whole PowerShell module, and it doesn't have to download that atomics folder, which is that huge library of scripted cyber attacks with supporting source files and binary files, all that intentionally look like malware. And so when you download that whole atomics folder, it'll set off all sorts of alerts in your environment before you even start running anything. So if you want to be more light touch, you install Atomic Red Team on your test system, and then you just execute only the command atomics you're interested in against that remote machine. But that works over PowerShell remoting. So you have to be able to connect from your test machine to the machine you're trying to test on with PowerShell remoting. So, those features have to be turned on and things have to be reachable across the network, the firewall, have to be open, etc. So that can be a battle. So with over 800 atomic tests across multiple operating systems, it can be a little, it can be a lot overwhelming to get started. And so I've worked up there's a link to a little spreadsheet here of my favorite atomics. Of course, this presentation and everything has been Windows centric, and these are Windows atomics. But these atomics are things that are kind of using, for the most part, built-in features of Windows that can be used for good and evil. So in other words, they don't end up getting blocked by default because like sysadmins need to use them for real reasons. And yet they tend to get mostly used by hackers. So you could keep an eye on that. So my advice is to start slow, start in a test environment, start in the lab environment that I provide to you if you want to do that. Get to where you understand things. Do that from a network that you're not going to get in trouble from, if they see malware looking files coming down to your virtual machine. And get to where you just understand the tests and the tools. And once you get comfortable with certain tests, you can move on to more of a representative test environment for your organization, and you could build some automation around this. So we've built automation around all the tests that we run and all the detections that we have, and it marries those up and gives us a view of a detection catalog. So that automation is super helpful, and we have scripts that run atomics around the clock. Just want to remind you that on that wiki, there's a page on contributing. If you're interested, there's actually 249 contributors right now. So I'm excited for someone to be that lucky 250th new contributor and to get their Atomic Red Team t-shirt. So we have a few minutes to talk about the labs. So I linked in, below the video and in the chat channels, you'll see the links to the slides and to the labs. And when you click on that link, you get brought to this page here, the Atomic Red Team Hands-On Getting Started Guide. You can do these labs on any Windows machine that you have, or virtual machine, but I recommend virtual because you can kind of botch up your Windows install, like if you ran all the tests at once or something. There's so many things that it disables and does, that it makes it hard to even get it back to where it was if you ran them all at once with not really knowing what it does. So I recommend a virtual machine just so it's disposable. I do give you instructions to set up your lab like we do for the on-demand class. So if you're taking the 16-hour class, you'll set up the same lab environment where you install VMware Workstation Player and you download and install a couple VMs. You don't need to do the Caldera Linux VM to do these labs because we're only going over Atomic Red Team on Windows, so you can skip that step. That's only if you're taking the class, the full class. And then you can run through each of these labs. And if you run into problems, I'll be on the various, there's links at the bottom of this lab document to join the Atomic Red Team Slack workspace. You can find me there, or on Antisyphon or Black Hills Discord channels as or1=1. And you can let me know if you're having troubles with that so that I can clarify the instructions and stuff, because they are pretty new instructions because we're just releasing the on-demand version where you set up your own labs for the first time. Here's the link to the 16-hour class if you're interested. Like I said, probably early next week, the on-demand version will be available, which just means you can watch the videos and go through all the labs on your own time from a learning class website. And let's see, I'm ending a little early. I should have demoed a little more, but we got time for questions. So the wrap up is the Atomic Red Team. That's the really valuable thing here. It's the library. It doesn't magically do anything by itself other than inform you of all the procedures. And then you can use a variety of execution frameworks if you want to automate the execution, which could be Invoke Atomic Red Team. It could be Prelude Operator, MITRE, Caldera. There's commercial products that read the library, Atomic Red Team library, and run it as well. this is the Slack workspace where you can catch me. You can join that there for free. There's over 4,000 members of people who are interested in attack emulation. So you can, and it's a very supportive community. You can go in there and ask for advice about how if anybody's doing things a certain way or has ever seen a certain thing, anything kind of in the space of attack emulation. So it's a great community there. And that's all I have. Oh, are there some questions we should go over?
No questions yet, but I wanted to say thanks, Payload, for following. Tedious One, thanks for following. Glenn, thanks for following. Not thanks for following. We appreciate you following us on Twitch. And you're like, why Twitch? Because Twitch, I spent like 2 years on Twitch. I enjoy Twitch. Not a good Twitch. Twitch. Serena, any questions after watching Carrie do her thing for the last? You're on mute. Mm-hmm. No, it's totally good.
Not currently.
Is Slack the main comms channel to Atomic? I guess.
Yep. There's a lot of discussion about, even questions like, does Atomic Red Team work on Linux? Is there a Python execution framework? Is there a way to chain atomics together to emulate more of an adversary instead of individual atomic tests? And there's channels dedicated to each of those. There's a general channel, an Invoke Atomic Red Team channel, a Python execution framework channel. There's also some Discord and Slack channels for MITRE. If you have questions on that, there's links in the lab to that, and also for Prelude Operator and Vector. So yeah, but for Atomic Red Team, yes, that's Slack channel that you can join. You can also find that link on the Atomic Red Team's wiki at the bottom of every page.
I think the most important thing for us to wrap up today is, can you please go back to the marble Rube Goldberg puzzle thing that's on? Could you just show us how big?
Yeah. Well, from here it looks about this big, right?
Yeah.
And that's actually how big I thought it was when I bought it. But this is an automated marble maze, and it's huge.
That thing, so misleading.
I thought it would take up this little space on the wall. Luckily, I had a ginormous wall, but with it being so far back, it looks tiny. But it has let's see, I can't figure out how to point in this, but it has this conveyor belt that takes big marbles. That's the other thing that threw me off too. When I saw the video, I thought they were the normal tiny marbles, but they're really big marbles. They go up the pulley and they get dropped off at the top, and then they can go, there's little switches that flip each time a marble goes by. So they can go down one of 4 ways. So they go down and go swirly, swirly, or they go over here, they go by 4 chimes. So it'll ding the chimes as it goes by here. And then behind me is a toilet bowl. So they end up down there going around in the toilet bowl. And then up here, oh, that's so weird. Up here is an arm. So it goes shoo and drops off. Mm-hmm. So it's a lot of fun. Mm-hmm. It took me and my kids 80 hours to put it up.
80 hours?
Yeah. Well, it's like 40 hours to get it on the wall, and then the next day it fell off the wall and you had to do it again. And then just fine-tuning it to actually everything work took a lot more time than I expected. But it was a lot of fun. It works great now.
So at no point you thought about just throwing away and just giving up?
No, but I gave up on the idea that I would ever reconfigure it in a different configuration because I ended up getting the hot glue gun out and just there's tons of hot glue on there, just holding everything exactly where it needs to be, because it kind of shakes and gets out of whack, and then you have to adjust it again. So and also I didn't want it falling off the wall, so instead of the magnet mounts it had, I added some screws straight into the studs. So that thing's gonna be like that for a long time.
Well, Carrie, thanks for joining us. Thanks, everyone, for joining us today. We hope you enjoyed this. If you did, go ahead and check out Atomic Red Team. If you want to know how to get started, Carrie is also a wealth of knowledge. Go ahead and hop into that Slack channel. And I'm getting reverb. Is everything okay? Okay. All right. We come back here every Tuesdays and Wednesdays at 4:30, so you can always join us then. Anything, Carrie, before we go?
No, thanks for joining, and reach out if you have more questions.
All
Thanks.
right. Thanks, everybody. We'll see you
Bye.
next time. Bye bye. Ryan, kill it.